All right, here we go, back to our sample problems, and these are going to cover our new ones involving molar mass and density. Speaking of which, density, they ask in this first problem, what is the density of nitrogen at negative 25 degrees Celsius and 4.25 atmospheres? So our equation for density, I'll write it up here at the top. D equals mm, or just m, times times p, my fault, over RT. So I'm going to set up a list over here. M or mm, I choose mm, P, R, and T. M or M standing for molar mass. Since this is nitrogen gas, you need to recognize that it is diatomic, so that's N2. So the molar mass instead of 14.01 is going to be 28.02 grams per mole. Pressure, they tell us, is 4.25 atmospheres, right here. R, since the pressure is in atmospheres, we have to use 0.0821, and again, the unit for that is liters times atmospheres over moles times K. Temperature is negative 25 degrees Celsius, so when we add 273, to that, we end up with a temperature reading of 248 K. So again, with our equation, D equals mm times P over R and T, plugging in for molar mass 28.02, plugging in for pressure 4.25, plugging in for R 0.0821, and plugging in for temperature 248. Remember, everything on the top gets multiplied and everything on the bottom gets divided. So I'm going to take 28.02 times 4.25 divided by 0.0821 and divide by 248. I will get 5.85, and my unit is going to be grams per liter. The entire thing, grams per liter. Always double check that you get that out of your calculator. Next, what is the molar mass of a gas? So I look at my equations. My equation for molar mass is density times R and T all over P. So I set up a table, D, R, T, and P. D is 4.03 grams per liter. R, I'm going to wait because I'm going to check on my pressure first of all, which they tell me is 1,140 torr. Now I know I'm going to use my R value of 62.36 because I have to match my R with my pressure. Temperature is negative 73 degrees Celsius, so I add 273, and that makes it 200 Kelvin. My equation then, dRT over P, plugging in. For D, I plug in 4.03. R, I plug in 62.36. T, I plug in 200. P, I plug in 1,140, and I get a molar mass of 44.1. The units all cancel out, and I end up with only grams over moles left. The last one may be a little questionable as far as figuring out which law I'm going to use, or which version, because they want pressure. They give me mass. They give me the identity of the gas, they give me volume, and they give me temperature. Well, when they give me my identity of my gas, I then easily can figure out my molar mass. So I'm going to use the version from the other page where they gave me PV equals MRT over molar mass. I can also use any of the original days, not today's unit or today's gas laws. I could go back to my original ideal gas law notes and use those too. But this is an easy version. And since you have open notes, you might as well just use this. So my table PV MRT MM, pressure is question mark, V is 61.6 liters, M is 99.0 grams, R, I'm going to leave that for a minute, T is 125 degrees Celsius, which is 398 K. Molar mass for water, I have 2 hydrogens and 1 oxygen. That makes it 18.02 grams per mole. The R value I'm going to use is 0.0821. That means I'm going to have to make my pressure come out in atmospheres. M PV equals MRT over MM. P is what I'm looking for. V we said was 61.6. M is 99.0. R 0.0821. T we said was 398. And MM we said was 18.02. When I solve for pressure, I take my 99.0 times my 0.0821 times my 398. I divide by 18.02, and I also divide by 61.6, and I get a pressure of 2.91 atmospheres. So when solving these, again, you want to figure out what they're giving you, what they're asking you to find, figure out what form of the ideal gas law will help you figure that out. Hope this has been helpful. Again, let me know if you need any help. Have a great day.